Okay, so for 6.2b, talking about exponential depreciation, we talked about in class how this is more realistic, that really when you buy a new car, it loses most of its value in the first couple years, and then it kind of can taper off. So this is a bit more of an accurate representation, unfortunately, because it works out worse financially for you. So let's go ahead and read the first question. We know that we are using a different formula for this because we're talking about exponential depreciation, and I need to pull that up on the formula sheet. I always forget to do that. Okay, we'll have this here for us to reference in just a second. Okay, so Sam purchased a new car for $23,000. He was told the car depreciates exponentially, so this is how we know that we're using a different formula. If it said straight line depreciation, that would be the y equals mx plus b. Depreciates exponentially, we're going to use that one. At a rate of 7.66% per year, write the exponential depreciation formula for his car. So once again, in the same way as last time when it said write the equation, and our answer was a y equals mx plus b. Since it says write the formula, that's also going to be our answer. So looking to our formula sheet, this is the formula right here for exponential depreciation. They're going to ask us again to write the formula, write the equation. Keep in mind here, down here, I have a little note. If you are asked to write the equation, we leave the y and the t. Just like here, we leave the y and the x, and then that's our answer. We need to leave the y and the t because t is actually, whoops, click it on this things. T is actually x. Like if we were to graph it, time would be on the x-axis. So I'm going to copy this over, exponential depreciation formula, y equals a 1 minus r to the t. And again, we just copy that from right here. So in the same way, like I said, that the y and the t are going to stay put, we have y equals, we need to drop in our a. I have 1 minus, we need to drop in our r, and the t stays put. Because again, if you notice, we don't have any time here. Yeah, they don't tell us a number of years, excuse me. It's because, again, we can use this formula to make predictions for any amount of time. So we're going to leave t there so that this is a formula we can then use later if need be. So let's read. It says that, I keep clicking the wrong things, a is the starting value of the car. So what am I going to put in for a? What's the starting value of the car? 23,000, right? So that's going to go here. I have 1 minus. We know what r is, and we know that I cannot write it as 7.66. What should I put there? 0.0766. Again, if I go 7.66 divided by 100, you get 0.0766. That's how we know this 0 is here, is when you divide it by 100, it appears. Yeah. And that's actually it. You can leave it like that. Yes, we could do 1 minus 0.0766, but you can actually leave it like this. That's how I'm going to write it. And that's the formula. We could then use this formula to predict, after a certain number of years, how much the car could be worth by plugging into t. Again, that's the point of this, is making predictions for the future for how much your car might actually be worth. So let's go ahead and try it again, actually right here. Do this part first, then we'll talk about the next part, right? The exponential depreciation equation, that means we want one of these. We're plugging in the a and the r, and then make sure you leave the y and the t. Go ahead and try it. Okay, so y equals, because I'm writing the equation, a is the starting value, 26,600. I have 1 minus, r is going to be 5.15 divided by 100. 0.0515. So 0.0515, and then just make sure, because I will trick you on this on the test. If you do not have that t there, it's wrong. So make sure you write the t, because again, this is our formula we can now use to predict the future by plugging into t. So you need to write the t if they say write the equation. And that's what we're going to do in this next question. How much will the car be worth after 4.5 years? So we know that's t. Now, because this formula is more complicated, and more in particular, because this formula has an exponent, we're not going to be plugging into y for this question. If you remember from the straight line depreciation, We did plug into y because it was just easy. It was easy to move stuff over. We just moved stuff away from the x and we were done. But here, because t is an exponent, you're not going to be plugging into y. You're only going to be plugging into t for this question. So we have y equals 26,600. 1 minus 0.0515 to the, this is my t, 4.5. Take a moment, go to your calculator, plug that in. This is going to be an estimation for the value of the car after 4.5 years. To the 4.5. Okay. You should have gotten, you should have gotten 20,967.64. Now that makes sense because this is less than what we had to start, right? If I end up with a bigger number than what we had to start, something went wrong here because we're depreciating, not appreciating in value. Make sure I got this right here real quickly. Good, okay. Okay, so that's it. That's all you're going to be asked to do. You're either going to be asked to write the equation or plug into it. So you're going to try it one more time here. Go ahead, do both. Write the equation. Let me see real quickly here. Write the equation, and then we're actually going to come back to this one. So start off with writing the equation. Okay, so again, we want y equals a 1 minus r to the t. Y equals a is the 18,000. I have 1 minus, this is 0.064. If I divide that by 100, I will see that, to the t. So just for this question, once again, leave the t. If you don't do that, you're going to lose points, so be careful. Now for this next one, again, we are going to be plugging in, but keep in mind that the t we need is always number of years. So take a moment, figure out 70 months. How could we determine how many years that is? What should we do? Well, 70 divided by 12 will tell us how many years that is. It's probably going to be a decimal. Let's see. Yeah, so 5.83 we'll say. Years. So if you have months, t does not represent months. So if you put in 70, that would be like after 70 years. That's not what it's asking, right? So it's asking after 5.83 years. So take a moment, go ahead and rewrite it, plug it in, and see what you get. Okay, so 18,000, 1 minus 0.064 to the 5.83. So just be careful, guys. Again, sometimes you guys get so stuck in, oh, I have to do this every single time. We only had to do this here because we were not given years. In the last question, we did not take this and divide by 12 because we had years. So if you see in your homework one that says months, yes, you will need to divide it by 12 before you can use it in t. But if it says years, it's already good to go. Now, you should have gotten here, let's see, 12, 24.83. That's a dollar symbol. Okay, and we're going to actually go ahead and skip that one. So again, those are the only two questions you will be asked, is either write the equation or plug into it. Like I said, t represents the number of years. Just keep an eye out for if it gives you months or years. We need to know the years to be able to plug into it.